Good afternoon, my amazing class.
Good afternoon, my amazing teacher.
Happy 67th day of school. I hope y'all enjoyed making y'all's hats today. We are going to review finding opposites of positive and negative numbers. I asked you a while ago to make sure your desk was clear, so please make sure it's cleared. Before we begin our lesson today, I need to take this time to review these opposites. This was actually your test from this past Friday. I only graded about 5 people's tests, and I was ready just to put them in the trash can. So that basically was just telling me, okay, hey, I need to reteach this lesson. So this is me reteaching it, and you will retest tomorrow. So you are correcting your work and making sure you're understanding what is expected of you on this lesson for today. Do we understand? So this is just going to be a quick review, making sure you do know how to write equations. On the test tomorrow, you are not expected to use this answer column on the front and the back. Get it? Got it? You will only have to write the equation and the answer down right underneath. So please make sure you're paying attention of how I'm doing it so you know what is expected of you tomorrow. You will have to write the equation. This first one is the opposite of negative 28. If you open the parentheses twice, you have to close it. They say opposite of in word form here. This is the first they mention. And then they say it in symbol right here with this negative and the open parentheses. So that's how I knew that this is a double opposite. And then when we have a double opposite, the answer is the same as the original number. So if I look inside all of that parentheses, the original number is negative 28. It doesn't matter if it would have been positive 28. It would have been a positive 28 as the answer. But no matter if it's negative 28, which it is, negative 28 because it's a double opposite. Do we understand? And because this one was full of double opposites on this test, if I would have graded it and you did not understand double opposites, you probably would have made around a 60 because it was that many on there. Okay? That's why I stopped grading, because you didn't understand the double opposites. Okay? So let's double check here. Opposite of, word form. Oh, and I see the symbol opposite of negative 20. And I close it twice, and we get negative 20. All right, so there was another one with a double opposite. Now this one, it just says the opposite of negative 15. And guys, the opposite of negative 15 is 15. A positive 15. The opposite of 10 is negative 10. The opposite of negative 27. The opposite of 44. The opposite of 40. I'm going to wait a second. Give me a thumbs up once you've corrected your work. And you're good to go. On to the next few. Alright, my next opposite of, the opposite of negative 40. Opposite of 3. Opposite of negative 43. Opposite of negative 13. Opposite of, the opposite of negative 6. Opposite of negative 43. Opposite of, the opposite of negative 24. Opposite of negative 44. Opposite of negative 14. Opposite of 24. The opposite of negative 21. The opposite of negative 24. Opposite of 50. Draw one more and say it with me as I write it. What's that symbol mean? Okay. But now that I have that there, opposite of 67 is 67. The opposite of 67 is 67. Let's do one more. The opposite of 76 is
76.
So do you understand double opposites? The answer will be the original number. Turn it over. No, you just fix it so you know what to study tonight. Turn it over. You have to be careful because if they're both negative numbers, the number closer to 0 is greater. Negative 35 is closer to 0, so that means negative 72 is less. Negative 42 is closer to 0, so that means negative 43 is less. My next one, it's a negative and positive. A negative is always smaller than a positive. Negative 90 is closer to 0, so negative 91 is less. Negative is always smaller than a positive. This one, negative 61 is closer, so it's definitely going to be greater than negative 81. A negative is always smaller than a positive. A negative is always smaller than a positive. A negative is always smaller than a positive. Negative 88 is not closer to 0. Didn't mean to circle that one. Thank you. Alright. So negative 88 is less than negative 44. Is closer, so negative 62 is less than negative 36. Negative is always smaller than 49, a positive. Negative 22 is closer, so it's going to be greater. Negative 33 is closer, so that means negative 34 is less. Negative 67 is less than 64. This one, negative 56 is closer, so it's going to be greater. Negative is less than a positive. Negative 60 and negative 59, so negative 60 is less than negative 59. Negative 30 is closer, so it's greater. And a negative is always smaller than a positive. One more. What if I said... What is 94 to 90? Okay, what if I did, let me think. There was one that I was going to do. Hold on. What if I said, 94 is what to 94? Negative 94. Negative is always smaller than a positive. But what if I said 94 to negative 94? A positive is greater than a negative. I don't know why that line's there. Okay. Alright, so please make sure you study that for tomorrow's test. Alright, now getting back onto the lesson that we're learning about today. Please get out this packet that was handed out. The problems that we don't do will be extra practice for you if you need it. It says the point below represents 0 on the number line. Draw a number line to the right starting at 0, then follow the directions as provided by the teacher. So this little point right here is 0, and it says draw a number line to the right. This is math class, not art class. We're trying to be fast and efficient. Get it? Got it? Okay. So I just went to the right. If we look at the end of this number line, we can see the greater than symbol. And this is also going in a positive direction. Because to the right of 0, we have what kind of numbers? To the right of 0, what kind of numbers? And if I went to the right of 0, lately we've learned we also are going to go to the left. And this is the left. And if we look at that symbol right at the end of this line, that is the less than. And it goes in a negative direction. So if we're going to the left of 0 on this number line, it's going to be -1, -2, -3, -4, and -5. What kind of number line did we create? And then, if we talk about a horizontal number line, what was the next thing we talked about on our last lesson? Vertical. Well, let's first go in a positive direction. Which way am I going to go for a positive direction? For a vertical. Above, up. So I heard above. I heard up. But again, this is a positive direction. So above 0, we have 1, 2, 3, 4, and 5. And if I go above 0, I'm also going to go below to extend out my vertical number line. And we can say below, we could say down, but again this is a negative direction. So that means we're going to have negative numbers, negative integers, even negative rational numbers. What's the difference between an integer and a rational number? What does rational numbers also have? They can be decimals, they can be fractions, they can be improper. Remember, integers have to be whole numbers. That's right. And what kind of number line did we just draw, guys? Vertical. And I'm going to label it going down just like this. Is this anything new to you? No. But what does it look like that we drew? Looks like we drew a coordinate plane, right? And that's what we did. Today, we're locating ordered pairs on coordinate planes. This is a new standard. It's 6 NS.8. 6 NS.8. And yes, we'll have a new sheet protector. We are done with 6 NS.5, which was literally everything that we just did. We're done with 6 NS.7, which were about rational numbers. NS.5 was about integers. NS.7 was about comparing and ordering rational numbers. Well, now we're starting 6 NS.8, and that's locating ordered pairs. Another word that you might hear, instead of locating, you might hear plotting. Have you ever heard of that before? And instead of ordered pairs, they could say plotting coordinate pairs. And let's talk about what those are. Well, we've already discussed it for 2 days back when we learned about ratios, because ratios are on ratio tables, right? And on a ratio table, you learned back in 5th grade that you can have a table dealing with X and Y, okay? So I'm just putting that reminder there that this lesson is super easy because we've already done a mini lesson on coordinate planes. And how many connect the dots have we done where we drew something out? Okay, so you are already familiar with this, okay? So this is really just making sure you understand the coordinate plane, and tomorrow you get to see the 6th, 7th, and 8th grade lesson on reflecting. That will be the true lesson for 6th and 7th grade. I'm not joking, okay? All right, so trying to think of anything else before I begin. All right, so here we go. So 6 NS.8 also involves absolute value. Now, I did not teach this lesson to you personally this year. You watched a what? Video. Well, I want to go ahead and tell you, and I'm going to say it out loud on this video, that when I went back to Google Classroom and I get to see exactly what y'all work on, because you know you click on the link through Google Classroom that day, I had about 6 of you, not even joking, fast forward through the video. I did not teach you absolute value personally, so I am worried that you're not going to know what absolute value is. Okay, you have to know what absolute value is. So if you know that day that I was not here, I think it was Thursday, you remember I had to come in, get things ready for y'all, and I told y'all exactly what you needed to do. If you know, and I know who you are, if you fast forward through that lesson, you might want to go back and rewatch that what? Video during wind time. Do we understand? Because I need you to make sure you understand what absolute value is. And we'll have a little mini lesson on it today to make me feel better about making sure you know a little bit about it. Okay? But if you fast forwarded through that video, you need to make sure you go back and watch the absolute value video, and it's still on Google Classroom. Do we understand? Yes, ma'am. All right. Absolute value is involved in this, and we'll see a little bit of it today. So, moving on, we have this lovely coordinate plane. In 5th grade, you worked in this area. Do we know what this area is called? How about now? Do we know what this area is called on the coordinate plane? Quadrant what? Quadrant 1. Y'all see the quadrant 1 right here? On the top right of the coordinate plane. It's on the top what? Right. And I'm going to zoom in a little bit now. And I really, honestly, am just wanting to look at quadrant 1. Okay, do y'all see quadrant 1? Quadrant 1 is touching the right side of the vertical. No, it's not. It's touching the right side of the horizontal line, and it's touching the top of the vertical. So if we think about our X and our Y ordered pair, what kind of numbers, integers, rational numbers, what kind will they be? Well, look at our numbers here of what quadrant 1 is touching, what quadrant 1 is made up of. Positive. I'm going to put a plus sign for positive. And then our Y will be, are you looking? Positive. I know. But what is positive talking about? Positive and positive. It's talking about positive numbers. It can be whole numbers. It could be positive fractions. It could be positive mixed numbers. Positive improper fractions. Positive decimals. Whatever is here. Okay? Some of you are like, I can't remember which one comes first. Well, last year, Miss Denise told you about, and I'm going to write it up here. Last year, Miss Denise, back in 5th grade, told you about the run before you what? Before you jump, right? Okay? We can still apply that, okay, to help us remember. We're going to run, and then we're going to what? Jump. Okay? For quadrant 1, our numbers are going to be positive and positive. So that means X and Y are both positive. And again, that's not a T. That's a plus sign for positive. Because do we want to keep on writing out positive? We will if we have to. Okay? Now, which way do you think quadrant 2 is going to be? Which way am I going to move? Left. That's right. Alright. So this is, I'm going to end up running out of room, but whatever. Alright, here we go. Quadrant 2. And what do y'all notice I'm also putting off to the side of these? I put 2 and what's that called? Ooh, my fingernails. Our Roman numerals. So we have the number 2 and then we have the Roman numeral. You need to know what both of them look like. Get it? Got it? Okay. Let's see who's checking out. Alright, bye Marley. You'll finish this video tomorrow. Finish this lesson tomorrow. Okay? It will be uploaded today, hopefully. If not, it will be tomorrow. We'll do it tomorrow. Alright, you ready? Alright, so here we go. Our X and Y here. We're going to run, not going to the right where it's positive. We're going to run to the left for our X, which is negative. But our Y remains what? Positive. Because when we jump, we're still positive. So our X is negative. And our Y is positive. Now, which way do you think we're going to go? Which way am I going to go now? I'm done with quadrant 2. Now I'm going to go down to quadrant 3. Then that Roman numeral looks like 3 I's. Okay? Now this is where that run and jump doesn't work. You still run, but now we're dropping. So guess what? I'm going to go back up to the top, and instead of saying run before you jump, I'm going to say run before you drop. Okay? One of the two. Okay? So I went back up to the top. Did you write down drop? Okay? So here, bye Marley, have a great day. So when I look here, I'm running in a negative direction. My X is negative, and my Y is also what? What's touching quadrant 3? Negative. Okay, somebody in first block went, it looks like somebody sleeping, it looks like an owl, whatever you need to know. Quadrant 3 are both negative numbers. The X and Y, both negative. Alright, and then which way am I going to go? To the right. And it's going to be quadrant 4. And when I run here, what's up with my running? What am I running towards? Positive, because it's touching positive numbers, quadrant 4 is. But we're in the negative because they're dropping. Okay? So my X is positive, and Y is negative. We're almost done with this little part here. But do you remember at the top when they said start at 0? Starting at 0 has always been our origin. And when we created this, and I'm going to zoom back out, when we created this, we know that our horizontal line is called our X axis, and then our vertical line is called our Y axis. And you can put a box around that, a circle around that, so you can know that that is important. Let me think. I don't think I left anything else out there. So now we're about to speed up. It's not going to take long. That was the longest part of our lesson right there. Ready? All points on the coordinate plane are described with reference to the origin. What is the origin and what are its coordinates? Well, the origin is going to be 0, 0. Okay? It's called the reference point. But we also learned, back when we learned about NS.8, that our reference point is also called the starting point. And that's it. And we're literally going to repeat everything that we've talked about right here. To describe locations of points in coordinate plane, we use ordered or coordinate pairs of numbers. Order is important. So on the coordinate plane, we use the form X and Y. And the first coordinate represents the X, and that's when we are running. Okay, we're going to run to the left or to the right. And then for the second coordinate, it represents the y-axis, but here we're going to either jump or drop. So is any of this hard? No. So now we're going to turn our page, and we're not doing the back. Which part do you need? Okay. So now we are not going to go to the back. The back is extra practice, but now we're going to go to example 3. Go to example what? 3. And it says quadrants of the coordinate plane. Do y'all see example 3, quadrants of the coordinate plane? Okay. So let's label this. Again, what is this area called of the coordinate plane? Quadrant 1.
Oh, yes, it is.
And then we go to the left, and it's quadrant 2. Then we go straight down to quadrant 3. And then we go to the right quadrant 4. Then it ends up going back in a constant circle, and it's called counter clockwise. That's the direction it's going in, counterclockwise. Okay? So that was just a quick review. Now we're going to go practice plotting these points, and I'm going to zoom in. Okay? Thumbs up when I can move on. Okay, so we're going to locate and label each point described by the order pairs below. We're going to label them as A, B, C, D, and E. I don't know if you noticed something that's a little bit different from 5th grade, but if you look at here, do you see them numbered? Are they numbered? No, but we see the unit what? Squares. Do you see the numbers here? Nope. This is 0. Well, that means this full square is 1. This full square is 2. I need to go find 7, 2. Remember, I'm going to run to the right because it's positive, and then I'm going to jump up what? 2. So here we go. 1, 2, 3, 4, 5, 6, 7. And then we're going to jump up 2. And I'm going to label it A. What quadrant is A in?
Quadrant 1.
Because they're both what kind of integers? All right, B. Where am I running to? The right or the left? I'm going to run to the right because it's positive. How many am I running to the right? 1, 2, 3. And then I'm going to jump or drop? Down. 1, how many? 1, 2, 3, 4. And that's letter B. But what quadrant is it in now?
4.
And quadrant 4 is obviously made up of positive and then negative. All right, C. I got to run. Which way am I running? Right or left? Right. And then, yep, one time. And then I'm going to go down, drop 1, 2, 3, 4, 5. And I'm going to label it C. What quadrant am I in?
4.
And again, it's a positive and a negative. All right, D. Here we go. I'm back at the origin. I'm back in the starting point. I'm back at the reference point. Many different names for origin. Okay, I'm running to the left. How many?
30.
1, 2, 3, and then I'm going to go up 8. I'm going to jump up 8. 1, 2, 3, 4, 5, 6, 7, 8. And that's letter what? D. And what quadrant is that in?
2.
And that's made up of a negative X and a positive Y. Now, you should be able to know, based off of this without plotting, that my X and Y and E is both what? My X and Y on E are both what kind of numbers? Negative. And we learned from our drawing that if they're both negative, what quadrant is it in? 3. So if you memorize that quadrant 1 is made up of all positive, and you memorize quadrant 3 is made up of all negative, it might help you shorten working something out, okay? But you can always plot it to check your work to see if it's in quadrant 3. So let's see. E is going to be going to the left 2
Go down.
and go down 1. And is it in quadrant 3?
Yes.
Yes. Okay? But if you can go ahead and memorize that, quadrant 1 is all positive X and Y, quadrant 3 is all negative X and Y, then you might not even have to plot it, because the question might be, where's this point at? Is it in quadrant 1, 2, 3, or 4? And if you know your X is negative, your Y is negative, and then it's obviously in quadrant 3. Get it? Got it? I need you now to go to the problem set. And I'm showing the notes here. Cool? Alright, do you see 1A? It wants us just to not plot it. Say what quadrant's it in. Alright, 1A is a negative 2 and a positive 5. Where is a negative and then a positive? Quadrant 1, 2, 3, or 4. Negative X and then a positive Y.
Quadrant 2.
Quadrant 2. So A is quadrant, and I'm just going to say quad 2 for time reasons. Get it? Got it? All right. B, what kind of number, what kind of rational numbers is it? Or integers, or whatever it is. Those are integers. Positive and then negative. Which quadrant has positive and then negative?
Quadrant 4.
Okay, I can call these integers because they're whole numbers. So C are integers because they're whole numbers, but what are they both? Negative. C, they're both negative. What quadrant is that in? Quadrant 3. Now, can I call D integers?
No.
What do we call them?
Irrational.
Rational numbers. They're called rational numbers. Because do you see the decimal? I can't call it an integer because that decimal's right there. So they're rational numbers. But what are these rational numbers? They're both what? And if both of them are positive, if both X and Y are positive, then it's in quadrant 1. Now, I want you, let me get this out, to look at E. Are y'all watching? If my X is 0, can I run anywhere? No, I gotta stay at 0. I cannot run anywhere. But I can, what? Go down to negative 40. Y'all see that here? Okay, I'm not asking y'all to put it on yours, but look. Y'all see that negative 4 there? It is not in a quadrant. It's on a what?
Number line.
It's on a number line. But which number line is it on? Vertical. But we call that the y-axis. So if we have 0 involved, and I want you to create a letter F. If we have 0 involved, And let's say this time negative 4 is my x and 0 is my y. So I'm going to run over to negative 4, but am I going to jump or drop? No. It's going to stay on negative 4. That is not in a quadrant. That is on a line. This one was a horizontal, and it's on the what axis? So we would have to label this one as the x-axis. Now, what if I said another letter, and my point is 0, 0, which I'm not going to make another letter, but what's 0, 0 called? Y'all should know that. The origin. Okay? So sometimes we're going to have points that are not even in a quadrant. They're on a number line, and they're on 0. So we're going to write that down real quick. So if we have a 0, so if we have a 0 for x or y, it is not in a quadrant. It is on, I should say that, but I'm going to say on an axis. Where is my whiteout? There it is. It is on a axis. On an axis. Said that wrong. Okay? But if both are 0, 0, both are 0, if both x and y are 0, it's called what? Does that make sense? Okay. Last question about today's lesson, and the rest of this is review. Not all of the next few pages are homework, so you'll make sure you're paying attention, and then we should have enough time to play the game, the 6-7 game. Get it? Got it? Okay. Jackie claims that points with the same x and y must lie in quadrant 1 and quadrant 3. What they mean by that is they same signs. So it means the x and y, remember the order pair looks like that. The x and y would either have to be positive and positive, and then negative and negative. Well, what quadrant has positive and positive? Quadrant 1. And what quadrant had negative and negative? Okay. And what did Jackie say it had to be? Either quadrant 1 or quadrant 3. So do you agree with her? So we agree. All right. So I just wanted to make sure y'all understood that questioning, because that was a really good question. So was today's lesson hard? Okay. So I want to make sure you understand what homework is. Homework will be 1 through 5 on the top, and then 2, 3, and 4 on the bottom. So everybody get to number 6 on the top. Everybody get to number 6 on the top. Get to number 6 on the top. So 1 through 5 is the top, 2, 3, and 4 is the bottom for homework. So everybody get to 6. And I do?
We do.
Select each number that would make this inequality true. When we have problems like this, a lot of people end up making simple mistakes on this, and I'm going to zoom in, because there's multiple answer choices that it could be, and a lot of us get a little bit lazy because we don't want to do extra work. We think, oh, I'm going to get it right, just because what it looks like. Now, can somebody tell me why I'm doing what I'm doing right now?
So we can know what's positive and negative to each number we bring over.
Okay. What was that inequality statement they said that it would be? Negative 50 is less than star. Well, this star is our unknown variable because they are asking us to determine which integers would go there. Okay? So I'm putting the integers there to see if it makes sense. Okay? This is where if they're both negative, you need to circle which one is what? Closer to 0, because then it's bigger. Which one's closer to 0 for negative 50 and negative 45?
Negative 50. Well, 45 I mean.
Okay, so is negative 50 less than negative 45? Is negative 50, which one's closer to 0?
Negative 45.
So that's bigger, right? Okay. Is negative 50 less than negative 45? Yes. Yes. Negative 50 is less because that's that sign that they have there. Negative 50 is less than negative 45. So A is an answer. Is negative 50 less than 50? A negative is always smaller than a. So is negative 50 less than 50? All right, one more time. Because somebody did say the correct answer, but not enough. You ready? Negative 50 is less than 50. So B is an answer. Both of them are negative. Negative 50, negative 90. Which one is closer to 0? So negative 50 is not less than negative 90. Negative 50 is what? Negative 50 is? Greater. So guess what I'm going to put on C? An X. Okay, which one's closer to 0? Negative 50. And if negative 50 is closer, then that is not a true statement. Negative 50 is greater than negative 52. So I'm going to put an X on D. Negative 50, negative 70. Which one's closer?
Negative 50.
So that means negative 50 is greater than negative 70. Do you see why the alligator, it could get confusing? Okay? That's why you need to know that less than is going towards the left. Greater than is going towards the right. And I think I wrote that incorrect, but whatever. Here we go. I'm going to put it over there. Okay? That is how you solve these problems over here without getting confused. Rewrite them to make it make sense. Don't be lazy. Rewrite them. You will see a problem like this on your test next week when we do a test on opposites, integers, rational numbers, comparing, absolute value. You will have a question like that, multiple of them. Okay? So do you see how I solved it? Okay. All right, everybody come down to number 1. When you have fractions, what did I tell you to do with these rational numbers? Turn them into, you can't turn a, thank you, decimals. Okay, so I'm going to rewrite these as decimals, so you need to put it in your calculator. 3 divided by 4, you should get a negative 0.75. And then it's asking you to compare it to negative 2/5, and what's negative 2/5 going to be?
0.40.
So negative 0.4, and I was waiting for somebody to say it, and y'all did say it. It's actually negative 0.40. Because 75 hundredths, negative 75 hundredths, goes to the hundreds place, so we need to make it go to the same place. Got it? So which one in normal time would 75 or 40 be closer to 0?
40.
Okay, so it's negative 40, negative 0.40 hundredths is closer. So negative 40 hundredths is closer to 0. Got it? So that means negative 0.75. So negative 75 hundredths is less than, because these are negative what? Numbers. Okay? So 2, 3, and 4 will be for homework along with the rest of the top. Everybody, let's review absolute value to make sure you understand. Okay, here we go. Are you ready? Absolute value means what's inside the symbol becomes positive. So everybody touchdown. Touchdown motion. Straight arms. Make sure they're straight. because that's an absolute value symbol. If your arms are not straight, if they're bent, you're doing parentheses, and parentheses means opposite of. Absolute symbols and opposite symbols are not the same thing. So you have to know the difference. So, mirror words.
Mirror words.
Mirrors off.
Mirrors off.
Everybody stop, look, and listen. Okay. Mirror words.
Mirror words.
Everything inside.
Everything inside.
These symbols.
These symbols.
Touchdown symbols.
Touchdown symbols.
Absolute value symbols.
Absolute value symbols.
Everything inside
Everything inside.
becomes positive.
Becomes positive.
Everything inside,
Everything inside.
the straight lines,
Straight line.
becomes positive.
Becomes positive.
If it's a negative outside,
Negative outside.
it becomes negative.
It becomes negative.
Here's off.
Mirrors off.
So find the missing value. Well, let's make it make sense. Put these lines around it because that's what all these stars are. The star is -9, 1, 19, 91. What is the absolute value of -9? 9. Also says absolute value means how far away from 0. So I could ask how far away is -9 from 0? That's what absolute value means, is the distance from 0. That's why it's positive. Okay? All right. So how far away is 1 from 0? So the absolute value of 1 is 1. How far away is 19 from 0? So obviously that's going to be my answer. Now, how far away is 91 from 0? 91. So saying the absolute value is 91. Okay? Now, this is the one I'm telling you about. Everything inside becomes what? Positive. So it was going to be 23, but then there was a tricky little negative left on the outside. So my answer here will be -23. Rewrite this as an equation. Absolute value of -22. That's the equation. Absolute value of -22. My answer is going to become 22 because it's saying how far away is -22 from 0? 22. Okay? Draw a vertical line for 4 to help it make sense. It says sea level, and what they mean by sea level is they mean at sea level. Well, at sea level means what? 0. And I literally put it right there by it. So it will be by 0 at sea level. It's right there by 0 on the number line. Did that on purpose so we don't have to rewrite much, okay? A bird is flying. So is that going to be below or above 0? Above. So the bird, I'm going to put a B for the bird. What number is that B going to be? So the bird is flying 14 feet above sea level. So what am I going to put? 14 for the B. And then a fish is swimming 10 feet below sea level. So I'm going to put a, what kind of 10? For that fish, it's going to be a -10. Get it? Got it? Which is closest to sea level? And I asked myself, ooh, how far away is that fish from 0? How far away? And I'm asking, is that fish from 0? One more time. 10. So the absolute value is 10. And then how far away is that bird from 0? Okay, do you see how these are both positive? Because we're talking about distance. Which one's closer to 0? Because we're talking about distance. The fish. How far away is the bird from the fish? Well, we already know the bird is 14 from 0. And we know the fish is 10 from 0. So from the bird to the fish, what do I have to do? Nah, add them. So, because if you think about how many steps away are they from each other, 14 plus 10 would be 24. You could have a question like that, okay? All right, here we go. Uh-oh, I need to fix it. -54 becomes positive, but there's a negative number on the and then 55 stays positive. So a negative is always what to a positive? Less than. Select each number that has absolute value that is greater than 16. So you better go put an absolute value symbol all around those and then answer it. The absolute value of -17 is? Absolute value of 16 is? Absolute value of -90 is? Absolute value of -8 is? Absolute value of 19 is?
19.
Now, which ones are greater than 16? A,
A,
C, and E. B would be called equal, and D is obviously less than. That was our lesson for today. We are going to have about 10 minutes to play a game, and then we'll start jobs. Get it? Got it? Okay. Let's tell everybody bye.
Bye.